AI data centers are being announced and built at a pace the U.S. grid was never designed for. And they need electricity that we don't have. Everyone talks about generation, solar, gas, nuclear, but one of the biggest pressure points is much less visible: substations. So let's level set for a moment. A substation is the critical middle layer of the grid. It's where electricity coming from power plants or transmission lines is stepped down. It's controlled, protected, and routed to where it's actually used, whether that's a city, an industrial facility, or a data center. Substations aren't just passive equipment. They handle voltage conversion, protection, switching, and control, and they're designed around very specific assumptions about load size, growth, and behavior. And that's where the challenge comes in. Today, we're going to talk about what's actually happening at that level of the grid, why AI data centers are fundamentally different from traditional loads, and what that means for utilities, developers, and communities across the U.S. My guest today is Ben Watkins, a professional engineer and vice president at ARM Group. Ben works at the intersection of substation engineering, grid infrastructure, and large-scale project execution, supporting complex energy and industrial projects across the United States. ARM Group is a multidisciplinary engineering firm that works closely with EPCs and project developers, providing substation engineering and overall project engineering, especially on projects where grid integration becomes the pacing item. This isn't a theoretical conversation. Ben is working on these challenges in the real world, and that's exactly why I wanted to have him on. Hey, Ben, welcome to the Clean Energy Edge.
Hey, thanks, Russ. Thanks for having me on the show.
Well, let's get right at it. I want to start at the top here. So AI data centers, they get talked about a lot, but I think some people confuse regular data centers with AI data centers, and there's really a difference there. So can you explain a little bit the differences between, let's say, traditional data centers and these newer AI data centers?
Sure, that's a great question. So with traditional data centers, a lot of times what we're looking at is a building filled with a lot of servers that is just housing data and information for, this could be for various websites, there could be web servers in there, there could be things hosting all kinds of various web platforms, data being held even maybe just for locally for a hospital, let's say. That's also maybe more of a traditional data center. And they have, for the most part, fairly stable load profiles. They're the load that the amount of energy that they're consuming from the grid could be somewhat stable, or, it could go up and down, but nothing extreme out of the ordinary with a traditional data center. And AI data centers are all the rage and all the buzzwords a lot, especially if you follow the energy and power industry. And there's even some, recent publications on some of the PJM interconnections and issues going on there. A lot of it is based because of the nuances related to AI data centers. So AI data centers, it's very similar to a traditional data center in a sense. That's just a building filled with a bunch of server racks and a lot of energy consumption that was already there at a base level. But the difference with a lot of the AI data centers is they can have some very severe fluctuations in their loads. So they can go, especially during their training and learning sessions or profiles that they're going through, that data center can go from maybe a 20% point of its energy consumption all the way up to, let's say, 80% of its peak demand and energy consumption in a matter of several electrical cycles, or 50 milliseconds, let's say. So you can have something that is requiring, 30, 40 megawatts to within 50 milliseconds, all of a sudden it is requiring 150 megawatts. And so that is a pretty stressful impact on the grid. And one of those things that gets impacted with that is, of course, the generation, but also substations, transmission and distribution systems that have to support that. So it's the fluctuations, especially related to those training sessions, that the AI data centers are experiencing that is different from your more traditional data center.
Yeah, your more traditional it's kind of kind of straight line as far as it's going to have some fluctuations, but when you're talking the AI data centers, especially the training, like you said, and I'm assuming it's whenever people are using AI, those are going to be the jumps. So it's hard to predict. I guess you can predict based on some historical data, but I mean, you're going to have a lot of fluctuations. Is really going to be the differentiator between a traditional, traditional data center and a regular AI data center. Is that fair?
That's very fair. It's very accurate. It's in a lot of ways, the looks, you might not even, if you walked into a data center, you almost might not even know the difference between an AI data center and a traditional one in some sense. But the big differentiator is the amount of fluctuations of the load. And it could be from training, it could be from the usage, but usually once things are maybe released for general consumption, the usage profile does stabilize a little bit, just because there's not a massive influx of users that are using it and users that are not. Where on the training piece, that is a very significant impact in the consumption, because it's doing a lot of processing very quickly and then can kind of ramp down, and then do a lot of parallel processing and then kind of ramp down. And so the grid is having to try to supply that demand fluctuation.
Yeah, and the grid really isn't built for that type of usage, especially the additional loads of data centers, whether it's standard data centers or AI, which is even more so. And that gets into the electricity part, needing a lot more electricity. And we know that interconnection with these utility scale projects to provide the electricity, that's always been, well, actually in recent years, it's become the incredible bottleneck. But tell us how substations play into that dynamic. And let's start with existing substation upgrades. And then I want to ask you about when new substations need to come into the mix.
Yeah, great question. So there are a couple different ways that substations kind of come into the mix there, specifically with interconnections and data centers. So when we're talking about a data center interconnection in the substation, we could look at it from the perspective of the existing transmission grid. Let's say you're connecting into one of the the RTOs or the ISOs, like a PJM or an ISO. They have to be able to supply that power to wherever you're proposing to interconnect in with that data center. So everywhere that's connected within a general local proximity to that interconnection, all of those substations are impacted. And usually there's even substations that could be impacted further away from that too, it's almost a cascading effect, right? Because as you stress this point in the grid, another point in the grid is likely having to make up for it. And then so there ends up being this cascading piece of maybe multiple kind of levels of substations and transmission interconnected facilities need to be upgraded because of a proposed interconnection at just one point in that grid. So a lot of those existing substations need to be upgraded. And then of course you have the new substations, as you pointed out. Sometimes there's just no way to interconnect without connecting through a new substation. So for some of these facilities, they may have on-site substations, and sometimes they may not only have on-site substations specifically for that facility that wants to go in, but there may be a substation that needs to be put in 5 miles away that will then allow that newer substation at the facility to also connect.
Yeah, there's so many variables. It's not just a cookie cutter approach, right? When you're talking about substations. So let me ask you this. What are the biggest challenges with new substations with regards to planning, siting, coordination, and let's just say overall timelines?
Sure. So the last one is really probably the most challenging piece as far as timelines. That is a huge concern with a lot of the projects, not only from the data center, but also other maybe adjacent industries, whether it's on a generation facility for, let's say, a gas plant or a solar plant or a battery storage plant. A lot of the equipment timelines is a critical piece now, where, if we were to go back 5, I guess almost 6 years now to COVID times, a lot of the pipeline for equipment really struggled to keep up with demand because of facilities having to shut down, various shipping issues, all of those reasons. And so COVID, and soon after COVID, there was a lot of issues with being able to procure equipment and get it in a reasonable amount of time that allowed your project to be successful. And then fast forward a couple of years, things started to get much better, whether that's transformer lead times, whether that's circuit breakers, outdoor circuit breakers, even insulators were an issue at one point a couple of years ago. Those were holding up massive projects just because people couldn't get proper insulators. And so we started to come back from that COVID obstacle of lead times and timing with equipment. And then with the AI data center boom, that has kind of created another variable of constraint on the supply chain for a lot of the equipment, to where sometimes you are designing for a particular project, whether it's a substation or some related piece. You don't have the ability to just make the decision based on what may make the most sense for that solution. Although you want to use equipment A, well, you can't get equipment A for 5 years. So now you have to use equipment B because that's actually available within a year time frame. And if it's not available within a year, the project is going in the trash. So there are essentially reasons for choosing equipment now almost based strictly on timeline, as long as it satisfies the technical requirements, even though it might not be the most optimum solution, let's say. So some of these scheduling and timeline pieces are certainly driving a lot more decisions than they would have previously.
Yeah, and whenever projects they get to this level of complexity, really the engineering coordination matters. So where does ARM Group typically come in on these types of projects? I'm assuming earlier is much better than later. That's been my experience. But what's a preference to get a quality engineering firm like ARM Group in the mix and helping with this coordination?
Absolutely. The earlier, the better. And even if it's not, working with ARM Group, I know it's a little bit of a plug there for selling ARM Group to say, bring us on as early as possible. But I would just say in general, it's best for anyone developing and building a project to include the engineering firm as soon as possible, even at early site feasibility, just to make sure there aren't any critical issues that's going to shut the project down. And so from our perspective, we can do all of that early site due diligence, critical issue studies, desktop reviews, just to make sure there's not a massive red flag that's going to really derail the project before it really takes off, and also may provide a way to establish some guidelines and requirements for the project early on that then flows through for the rest of the project. Because that's a common hang up with a lot of projects, is just poorly communicated requirements at the beginning, where you can have people end up having to redo designs later on down the road because of requirements at the beginning that weren't as clear as maybe they should have been. So involving that engineering expertise at the beginning, that really help establish what are we trying to do, what are the sandbox that we are playing in, and making sure everybody is kind of singing from the same sheet of music in order to move the project forward.
No, that makes a lot of sense. And with regards to, let's call it AI driven load that continues to accelerate, what changes do we need to have in how we plan and deliver just overall grid infrastructure? Because this stuff doesn't seem to really be slowing down. What would you say kind of big picture needs to change in the approach for developers, utilities, anyone that's wanting to supply electricity to these types of projects?
Sure. What we are starting to see more and more is an emphasis on, if I could lean into the generation side of things, is how quickly the generation technologies can ramp up and keep up with the load. So there is certainly a component within the substation realm, as far as, hey, if you have tap changers, let's say, right on the transformer, that's going to adjust based on a variability of a load, you definitely need to make sure those things are keeping up appropriately or not for a project, and any kind of switching is not making poor decisions based on rapid load fluctuations. But the generation, it needs to be able to ramp up and ramp down very quickly. So a lot of times that's a becoming more and more important piece in some of the electrical modeling that is being required to make sure that this project and that generation can support the load profile that's being placed on it. You know, if your generation, sure, you can supply 200 megawatts, but how quickly can it fluctuate between 250 or 100 and 150? And what does that ramp up profile look like, the ramp down? How does it respond to any disturbance that you happen to place into that system?
Well, that's really where we see batteries making a big difference. It's instantaneous instead of a ramp up or ramp down, right? So that's a key component. Do you see this more of a utility challenge, a regulatory challenge, or just a coordination challenge when we're talking about this piece of it?
I unfortunately, or fortunately, depending on which way you look at it, think it's all of the above. I think there's very much a piece of it that is the utility understanding and having proper requirements and regulations for how they're um, requiring either loads from a data center or also any new generation that they're bringing on, whether that's through an independent power producer, an IPP, or some other method, making sure that things are relevant for that perspective. But also, there's just the customers or the generation providers, making sure that they are properly coordinating with those requirements, and that there isn't a disconnect where we are trying to um, uh, utilize a process or procedure that was perfectly valid and made sense 20 years ago, but with today's load profiles and generation requirements may not make the most sense for today. So I think it's across the board, and I think people are doing a really good job of this. It's just needing to continue with the path that we're going on, and that comes all the way from the ISOs to the utilities that may be within that ISO, all the way to the generation producers, all the way to the data centers. Everybody has to be on the same page, or else we're not going to be able to maintain the pace that we've been going on with ramping up more and more load.
Well, and let me ask you about the coordination just in general. Whenever we're talking about, it seems like every once a week you hear of a new data center being proposed for an area. What are the actual communities and the states and stuff like that? What are they actually doing, right or wrong, to bring these data centers in with regards to the power needed to handle these big electrical loads? Are some places doing better than others? That there's some lessons learned, or is everybody just kind of figuring it out as they go and kind of stumbling through this?
Yeah, so I think you're seeing a little bit of both, where you're seeing some areas where they've had more success, and wherever they are having success, you're starting to see more of those projects in that area because they were successful. And so some of the areas where we are seeing success is related to what they are doing as far as getting out in front of power requirements, the communication requirements, right? It's not a secret that a lot of the data center growth and activity is also tied to, fiber optic capabilities and connection bandwidth at those locations as well. So coordinating all of those things, and some of those areas, specifically within some of the areas that we are working, have had more success than others. And it's just a matter of, the key players making good, wise decisions on, what is important, establishing things early, from a community relations perspective, making sure there's plenty of avenues for anyone voicing concerns, and addressing those, and, proposing things that make sense for that community as well. And are there other benefits that a certain proposed data center can be applying to a given community, let's say? So there's a lot of different ways where we are seeing different locales treat things differently.
Well, let me ask you this. What advice would you give to a developer or let's say a municipality or any area community that's looking to maybe attract data centers? Because there's a big wave of demand that's coming this way for just overall electrification, but definitely for data centers in general. So, is there something you would say, hey, this is really a key point if you're looking to have additional load in your area for data centers? Here's one thing I would definitely do.
Sure. So a lot of that could be related to any ordinances that they have, and this is where our folks, especially on the civil and environmental side, really thrive, is understanding ordinances, whether it's counties, boroughs, townships, etc., and navigating what is needed from a permitting perspective or your natural resources, wetlands, things of that nature. And so, whenever there are very clear ordinances on what that jurisdiction wants you to do or doesn't want you to do, that can really help accelerate just the success of a project there, and really influences um, a um, a much more streamlined approach for the project when there's not a confusion over exactly what needs to be met in order to have a project be successful. So that would be my answer there.
Yeah, that's something we've seen with various projects. Just local permitting, interconnection, whether it's regional or just with local utility, that's a strain on a project in itself. But sometimes the local permitting can turn into a big issue. So that's a really good piece of advice. Um, Ben, this is one of those conversations that really highlights how much of the energy transition happens behind the scenes with substations and just the control rooms, interconnection points, all of that a lot of people just never see. So really appreciate you taking the time to come on and talk to us about that. And Ben, for people who want to learn more about Arm Group or connect with you, what's the best way for people to reach out?
Sure. The easiest way would be just through our website. So we have armgroup.net is our website, and there's an email is just info@armgroup.net. So it's arm is in the body part, and then group.net. So info@armgroup.net will get you into our email, and they could explore all of our different services through our website, whether that's in the energy and power spaces we're talking about, but also solid waste, natural resources, mining and quarry, all of these other things that we do as well.
Fantastic. Ben Watkins from the ARM Group. Thanks for joining the Clean Energy Edge. And thanks to everyone for listening. If you found this useful, subscribe, share it with your network, and we will catch you next time.
Thanks for having me, Russ.
Thanks.